All right, here's our last video in section 7.3, where we've been talking about graphing functions and domains. And a lot of the functions that we've talked about have been linear functions. And as soon as we can get it to look like slope-intercept form, y equals mx plus b, we should be able to graph it, right, using the y-intercept and the slope. We've also talked about nonlinear functions. Remember, absolute values, parabolas, polynomials. But if I asked you to graph it, would you know exactly where and what it looks like? You might know the general shape, a V, a U, squiggly, something like that, but do we know exactly what it looks like? And we might need to graph it and know exactly what it looks like to be able to determine domain and range. So if you're not sure how to graph it, well, you can always start by making a table of values. Pick some x's, plug them into your equation, find the y, and then figure out what points are on the graph. After you've plotted a few points, maybe you can see the pattern and figure out exactly where these graphs are at. Let's do a few. Looking at example number 5, it asks us to graph each function and determine its domain and range. Remember, domain is all the x values and range is all the y values. Looking at this first one, I have f of x equals the absolute value of x minus 3. So it's an absolute value graph. So hopefully we have an idea that it's going to be kind of a V-shaped graph. But we need to know exactly where this V-shaped graph is. And if you're not sure, make a table of values. Pick some x values, plug them in, and see what you get for your y values. That'll give you a whole bunch of different points. So plug in negative 2. Negative 2 minus 3 is negative 5. The absolute value of negative 5 is 5. Plug in negative 1. Negative 1 minus 3 is negative 4, but the absolute value of negative 4 is positive 4. And keep going and fill in as many x values as you need to. And then go over there and plot your points. I've got a point at negative 2, 5. I have a point at negative 1, 4. Whoop, I just erased it. I have a point at 0, 3, and 1, 2, and 2, 1, and what is this one? 3, 0. And then because I didn't start to see a pattern, it just looked like a line to me. I kept picking x points, x values, and plugging them in so that I can actually see that V shape. I plugged in a 4 for x and got a 1 out for y, so I know I have a point at 4, 1. Ooh, I'm starting to see that V-shape graph. Now that I know where that V-shaped graph is, I can go ahead and plot my points, connect my dots, and that's exactly where this graph is at. I know exactly where my function is at now of an absolute value of x minus 3 graph. Now that I have the graph, it's more easily, I'm more easily able to figure out what my domain and range is. Looking at my graph, if I'm looking for a domain, remember those are all the x values. Left, right, how far left does it go, how far right does it go, are there any domain restrictions? It looks like there's no holes, there's no denominators. This graph is going to go to the left forever, it's going to go to the right forever, it's going to include all x values, so my domain would be negative infinity to infinity. Okay, what about range? Remember, range is all the y values, and y is up and down. So how far down does this graph go? How far up does the graph go? And what y values are included? Well, if you look at this graph, it looks like it goes and it stops, and this is the lowest point that it hits, right? And so my lowest y value looks like it touches at y equals 0. And then it goes up from there and includes all the y values above 0 because it's going to keep going up and out. So I can say that my range is 0, including it, that's why they have the brackets. So I have 0 to positive infinity. Or I could say y is greater than or equal to 0. But the only way I knew that is by knowing exactly where the graph was. Because if it was shifted around any other way, it might be a little bit of a different range. So knowing how to graph it is kind of important there. Do you notice also any correlation between your equation and this number 3 and your graph, possibly? Yeah, maybe you've seen this in a previous class, but the number on the inside of the absolute value that's next to your x actually shifts your graph. It shifts your graph left or right, but opposite of what you think. And so in this case, it's actually going to shift the graph right 3 spaces. And that's exactly what it did. Instead of being at the origin at 0, 0, it's going to shift it to the right 3. So maybe if you knew that, you wouldn't have to do a table of values anymore. Another quick example, if I had, I don't know, h of x equals the absolute value of x, I don't know, plus 4. Do you see how the 4 is inside? Well, again, that's going to shift my graph left or right, but actually opposite of what you think. And so it's actually going to shift your v to the left 4. And so I can maybe quickly graph that absolute value graph, and then I can determine my domain and range. So just kind of a trick if you haven't seen that before. All right, what about b? b gives us a quadratic, right? An x squared. F of x equals x squared plus 2. We know it's going to be a U-shaped graph, but where exactly is that U going to be? That's important to help us pick out our domain and range. If you're not sure, plug in some values into a t-chart. Plug in -2 for x. -2 squared is 4. 4 plus 2 is 6. -1 squared is 1. 1 plus 2 is 3. Keep going by plugging in all different x's until you can start to see that pattern. Hopefully we know it's going to be a parabola and it's going to be a U-shaped graph. So I plotted those points until I found that pattern, and now I know exactly where the U is. We know that on a quadratic it's going to go to the left, it's going to go to the right, it's going to include all x values. So my domain is -infinity to infinity. But on this graph, what's my range? Well, how far down does it go on the y? What's the lowest y value that's included? Well, it looks like it goes down and it stops here at 2. It goes up from there and includes all the other y values above 2. So I can say, now that I know exactly what the graph looks like, that my range is 2 to infinity, including 2, that's why I have the bracket, up to infinity. But I only knew that because of being able to graph it properly. All right, do you notice any correlation between this 2 and my graph? Now be careful. If it were like this, x plus 2 squared, then I could say that this is left or right, like in example number 5a. But the 2 that we have now is actually behind the x squared. What that does is it actually shifts my graph up or down. If it's a positive 2, it actually shifts my parabola up 2 spaces. If it were a -2, it would have shifted my graph down 2 spaces. So maybe if you knew that little trick, you could have just graphed your parabola right away by knowing that little trick and not having to do the table of values. You can try it next time. Practice graphing not only linear equations, lines, but even absolute values and quadratics, making sure that you can graph them so you can properly determine the domain and the range of all those different functions.